Okay. So we're going to go through triangular inequalities. So today we're going to learn about two new theorems and how to apply them to finding the missing side lengths and angle measures. Okay, so before we get into this, we're going to go ahead and identify what an included angle is and what an opposite angle is and an opposite side is. So identifying angles and sides of a triangle. An included angle is an angle formed by two given sides in a triangle. So, for example, can you guys please lower it down? Please, thank you. So, an included angle is formed by two sides. So, here we have two sides. This angle that is created between those two sides is going to be known as our included angle. And this goes for every set of sides. So, for example, if I put this side and this side together, its included angle would be B. And so that would be its included angle. If I were to take BC and CA, its included angle would be C. And so that would be its included angle. So included angle is basically an angle formed by two sides. Okay, and the included angle is that angle formed by that side. So, for example, what is the included angle between AB and AC? Here we have AB. Here we have AC. So its included angle is A. Right? We can see that right there. That's the angle that it creates. And so our included angle would be angle A. Now, what is an opposite angle? An opposite angle is basically an angle opposite a side. So, for example, what is the opposite angle of AB? Here's AB. So we're looking for the angle opposite. So you look opposite and you see that its opposite angle is C. And so that would be its opposite angle. So for example, I was looking for the opposite angle of BC. Its opposite angle would be A. And if I was looking for the opposite angle of AC, its opposite angle would be B. So the opposite angle is quite literally the angle opposite the side. Okay? And then we have an opposite side. So basically this just goes backwards. So if I have my angle B, its opposite side would be AC. If I had angle A, its opposite side would be BC. And I have angle C, its opposite side would be AB. So, included angle is an angle formed by two sides. An opposite angle is an angle opposite a specific side. And then an opposite side is a side opposite a given angle. Okay? So given this information, we're going to get into these two theorems. The first one is the triangle parts relationship theorem. This basically says is one side of the triangle is longer than the other side of the triangle, and the angle opposite the longer side is larger than the angle opposite the shorter side. Basically, what this is asking us to consider is to consider the sides, and based on that, we'll be able to see different angle relationships. And what it's really saying is that opposite the longest side, so our longest side here is going to be the 16. Opposite the longest side is going to be the largest angle. And so obviously 88 is larger than 62 or 30. But what it also tells us is opposite the smallest side, so 7, is going to be the smallest angle, 30 in this instance. So opposite the longer side is the largest angle, and opposite the shortest side is the smallest angle. And based on this information, we can go ahead and we can kind of rank these different angles and sides. So for example, here we're going from largest to smallest. We've identified that BC is our longest angle and AC is our smallest angle, leaving our last side, AB, to be that middle angle. We've identified that opposite of BC is angle A, which in fact is our largest angle. And then opposite our smallest side is going to be angle B, which is that 30 degrees. And so that is going to be our smallest angle. Okay, and so basically this theorem we can use to differentiate or to list these different angle measures, whether it be from largest to smallest or smallest to largest, depending on what we're being asked to solve for. Okay, and so we're going to look at an example of this.
This is for you.
Thank you.
When you're done, what time do you have your conference?
At 6.
At 6 period?
Mm-hmm.
Okay. Well, I'll try to see if I can get with you a little bit before, and I'll tell you what we're going to do with that. Okay,
Okay.
that's for you.
Okay, thank you. Okay, so here we have an example problem. And basically what we're going to apply is we're going to apply this theorem we just looked at, which is the triangle parts relationship theorem, right? The triangle parts relationship theorem told us that we could go ahead and rank these different side lengths from largest to smallest, and we can rank these angles based on largest to smallest. Okay? So, the way that we can go ahead and solve this is this one's really easy because it tells us to start by substituting m is equal to 3 into each of the side expressions. This will allow us to order our sides from smallest to largest. So, it's telling us to substitute m is equal to 3. So, I'm just substituting 3 for m. And so there I have my measures for my different sides. One is 9, one is 8, one is 2. And I want to go ahead and rank this from smallest to largest. Okay, so the first thing I want to do is I want to rank my sides. So 2 would be the smallest, and 9 would be the largest, leaving 8 in the middle. Okay. And now we have our triangle parts relationship theorem, which basically tells us opposite the largest side is going to be the smallest angle. So here's our largest side. Opposite that is our largest angle, and so that would be angle X. Okay, then opposite our smallest side is going to be our smallest angle. Okay, and so that leaves our middle side. It's not our smallest side, not our largest side, just the middle side, so that's 8, and opposite that would be the middle size angle. And again, a reminder that we're going from smallest to largest. Okay, any questions about this? So I'll go ahead and just do one more example so that we can see. So I'm just going to give these different sides a random value. So 7, 6, 3. A, B, C. Okay? So what is our largest side? The 7. Opposite it is angle C. So 7 is the largest, which tells us that angle C would also be the largest. Our smallest side is side 3. Opposite that is angle B. So that is our smallest, which also tells us our smallest angle, leaving us with our last set, 6 and 8. Okay? So that's what this theorem allows us to do. Okay, so we also have the converse of this, and the converse is pretty simple. This one allowed us to say that depending on the side, we can determine the ranking of the angles. The converse will tell us depending on the angle, we can rank the side. So again, the converse, which is the hypothesis conclusion, so that's what's being done here. And this one just says if one angle of a triangle is larger than the other angle, well then the side opposite the larger angle is the longer side, and the side opposite the smaller angle is the smaller side. So basically the same thing, just reversed. So what is the largest angle? 88. And what we notice is opposite that is going to be our largest side. What is the smallest angle? 30. And opposite that is going to be 7. Okay? And so this is how, similarly, we're able to rank our angles and we're able to rank our sides. So it just does the opposite that. Instead of looking sides represent our angles here represent our sides. Okay, questions about this? Angle? Questions?
I have it right here. Okay.
Okay, so how does this apply to real world problems? So here we have an example of a real world problem. This one says Katie and Jack are hiking on 2 different trails. They reach the end of their respective trails with the straight line distance between the 2 trails being 5 miles. The angle between the lines connecting Jack and Katie, or the lines connecting Katie and the car, is 50 degrees, and the angle between the line connecting Jack and Katie and the line connecting to Jack and the car is 70 degrees. What is the largest distance to hike back to the car? Well, basically, it's just giving information about how these 2 individuals are placed in reference to the car. What is the angles in which they're placed in reference to the car? But Katie will be traveling this way to the car, and Jack will be traveling this way to the car. And what we want to determine is who has the longer distance. Well, what do we know? We know opposite the largest angle is the largest side, which tells us that this is the largest side. Well, what we'll notice is that's the side that Katie will walk down. Katie will travel down this side, the largest side, which means she will have the longest distance to travel. So therefore, Katie has the longest distance. Again, why is this? It's because that side that Katie is walking on is opposite the largest angle, and so therefore it would be the longest side. Okay? In reference to the angle formed, the 50. 50 would then therefore be smaller than 70. And so Jack would walk a shorter distance than Katie. That's kind of what we're getting at here. Okay. Any questions? So again, opposite the largest angle is the largest side. Opposite the smallest angle is the smallest side. Opposite the largest side is the largest angle. Opposite the shortest side is the smallest angle. Okay. The last theorem we're going to look at is the hinge theorem. This basically says if 2 sides of one triangle are congruent to 2 sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is larger than the third side of the second. Basically, it's saying if I have 2 triangles here, and they have 2 congruent sides. So the first criteria, they have to have 2 congruent sides. If they have 2 congruent sides, then what that tells me is now I want to look at the angles. They have 2 congruent sides, so I want to look at the angles. 52 has a larger angle than 40, and so therefore FE would be larger than CB. That's kind of what it's telling me. If I have 2 triangles that have 2 congruent sides, that third side, we can measure that third side by determining which of these triangles has a larger angle. Because in this instance, triangle DFE has a larger angle, that tells me that its side FE is going to be larger than ABC's triangle, which has a side CB. Why? Because it has a larger side, or a larger angle embedded in it, a larger included angle. Okay, questions? So let's look at that in a real world problem. This says a land surveyor is mapping out a triangular space property where one side of the property is 20 feet long and the other side is 30 feet long. The included angle between the sides is 20. A second surveyor maps another property with the same side lengths, but its included angle between the sides is 40. Will both triangular maps have the same dimensions? Well, let's see. What we have here is we have two triangles that share or have congruent side lengths. So next thing I want to look at is what is the included angle. What I notice is 40 is larger than 20, and so that would tell me that FE's third side will be greater than the third side of the other triangle. That being said, because FE is greater than CB, that tells me that the dimensions will not be the same, right? Because if FE is larger than CB, well, then the dimensions are obviously not the same. One's going to have a larger third side than the other because the included angles are not the same. Okay, any questions about this? And then the converse of that kind of does the same thing, but it goes backwards. The other one we looked at how the included side can affect that third side length. Here it's telling us how this third side length can affect the angle. So again, we have two congruent sides. And basically here I'm trying to determine which included angle is larger. Well, opposite the larger third side, which in this instance is 40, will be the larger included angle. So D would be larger than, we can look for, what is the opposite angle here? A. D would be larger than A. So in the other one, you're given the included side, and that will help you find the third. The other one, you're given the included angle, and that will help you find the third side. And in this one, you're given the third side, and that will help you find the included angle. Okay, any questions? No? So we went over the triangle parts relationship theorem and the converse of the triangle parts relationship theorem. That one allowed us to determine the relationships between the sides and those various included angles. So for example, if this is 7, this is 10, this is 3, this side would obviously be larger than this side. This would be the smallest side, and then that would be the middle side. So that allows us to rank those different angles. And then same thing, opposite the largest side, we have the largest. Opposite the largest angle, we have the largest side. Opposite the smallest angle, we have the smallest side. And then the hinge theorem and the converse of it says if we have two triangles that have two congruent sides, then depending on the included angle, if this included angle is larger, then it will have a larger third side. And then the converse says if this third side is larger, then it will have a larger included angle. Okay, so we'll go ahead and look at some more examples of this tomorrow. But if there's no other questions, you guys may log off, and I will see you guys tomorrow. Bye, guys.